We're up and running. We're recording. How's everyone doing? This is our second week already, right? The end of our second week. So we're making good progress. I'm liking what they've done with the curriculum revisions. It's cutting off about a week of suffering because what we're going to be focusing on today is the start of calculus, which really is the derivative, and we're going to do it in a graphical way. So we're going to look at it. We're not going to do algebra and a lot of things that is typically done, make you struggle through it, and then curse the curriculum, curse everything, think of dropping out, and then we show you all the shortcuts that are much easier. So this time, we're just going to get the concept down, but we're going to move right to the shortcuts on Tuesday, next Tuesday. So, yeah, I'm glad with the revisions. Usually this course has a little bit less of that anyway than the engineering part, but even that has been cut back. So we used to have some factoring and some algebra parts, and again, it's what typically in calculus causes the biggest problems. So we're going the bottom line is even when you get through it, there wasn't a great need for a lot of that. So where we are today, we've got through 10.1, 3, 10.4. I think I did everything the way I think. 10.1 and 10.3, I think I extended until maybe Saturday or Sunday for those, because I know first week you're adjusting, so if you hadn't gotten them done, they're still able. Maybe by extending the due date, you might still be able to get that 5% extra for getting it done on a day. I'm not sure, but anyway, you can still get them done. 10.4 and 10.5 from this week. I should have the due dates of, actually I think what I will do is I'll push them to like a Tuesday. Hopefully you can get them done by Monday, but then Tuesday, if you still had questions on them, we could go over them in class. And so hopefully, and also that gives you an extra day to get that 5%. So if you can get it done by Sunday, definitely going to get that 5%. If you get it done on Monday, you'll get that 5% as well. Okay, so we'll do that. And again, the prior lectures are going to be, especially this early part, are becoming less and less relevant because a lot of that was in there has been cut out. So far, I want to point out this one because the slide deck, I have a link to an applet that I'm going to play with a little bit here. But I think you might benefit a lot by pulling that up yourself, playing it with a little bit as you go through some of the problems. So I just want to let you know that that's probably going to be the easiest way is click here. I already did that, so you'll get. I have this on my Google Drive. The link takes you here. You'll get this same thing, and you'll be able to go through that. Okay, and then we'll take a brief look at some of the homework, because again, mostly what you'll be doing in the homework is either finding the slope of a tangent line, and basically you find 2 points and you do what we've been doing, y2 minus y1 over x2 minus x1. That's all you're pretty much having to do. We'll go through a few of them. And then in some of them, you don't actually have to do it, but you have to kind of see which way is the tangent line going. So if a tangent line's going up, what kind of a slope does it have? Think of a linear equation. If it's going up from left to right, positive, it's going to have a positive slope. If it's going down, negative slope. If it's level, horizontal, zero slope. So those are the three things we're really looking for. And we'll see that the zero slope is really important because the only time that's going to happen for a tangent line is when we have either a maximum or a minimum, and that's an important thing to find. So we're going to see that we can use this derivative idea for a lot of different things. And so with that in mind, we'll just kind of move into this. So this is, you won't see problems like this in the homework, but I wanted to connect it to what we're going to be doing with equations. We'll be doing the shortcut versions, but the way to get the average rate of change or the slope at a point, remember, is to take these 2 points, right? Remember, this is let's just kind of talk about what's going on symbolically here. Come on. Why is this? Okay, remember this is the point, it's 1.8 g of 8, the function value at 8, that's 1, so this is the y value, that's the x value. And the other point is 8 plus h, so we're taking 8, adding a little bit more to it, so we're getting down a little further in the x direction. And its y value is g of 8 plus h. And remember, here in this denominator where you just see the h, it used to be 8 plus h minus 8. Right? That used to be what was in the denominator, which is the x values being subtracted. The 8 minus 8 becomes 0, so all that's left is the h. But I want you to see this, and again, we're not going to manipulate this like is usually done in most calculus classes, but this is just a slope formula, and what they do is then we take the limit, we let h go to 0. And we're going to look at that graphically. So what that does is graphically it brings the 2 points together. And so we're getting the slope at a point, which is, might not seem like an amazing thing, but mathematically that's like nearly impossible. So that's what we end up doing with this one. We kind of did it, we can do it numerically, so we just can kind of analyze as h gets really, really small, and using the limit we can see that this value of this slope function, right, this y2 minus y1 over x2 minus x1, that slope, average rate of change, is getting pretty close to -5. It could come from the other way, we'd see the same thing. So that's all we're setting up with, is as this gets to some value, it gives us a rate of change. Okay, and again, so that's what calculus, the goal of calculus is. It's not to find out how much profit we're making, but how the profit we're making is changing. Is it going up, or is it going down? Is it going up quickly or down quickly, or or is it leveling off? So this is what calculus will allow us to do, is say, here's our current situation, what is the rate of change? And in this situation, the price of, I think this was the price of gold, the price of gold is dropping at a rate of $5 per hour, if you remember from the problem. I think that's all the setup, okay? So that kind of set the base of what we've been doing so far. Okay, and they go to this, and so yeah, when the time is 8 a.m. I think it was, when it first opened, prices were dropping by $5 per hour. Okay, so you want to wait. I don't want to go in at 8 in the morning if it's dropping $5 an hour. Let's see what happens at 9. And if it keeps dropping, let's wait a little bit and then buy your gold at a cheaper price. And then hopefully tomorrow it goes up. Okay, so here it is the link's at the top there. I'm going to use that. So this is what we do with calculus, is this is a generalized form of what they call the difference quotient. Again, a big fancy word for, it's the slope formula, right? Difference quotient, because we're subtracting the y values in the top. Remember, in the bottom, the x values got subtracted, but 2 of them canceled out, so that it looks like there's only one thing here. But this is just a slope formula. When we take the limit as h goes to 0, again, we can't let h actually go to 0, so you can't actually get the slope at a point. But using the idea of a limit, we're able to say, yeah, it fits, it works. Then that's what we're going to call f prime. This little thing up here is called a prime, so f prime, or the derivative of f. It's the rate of change of the function at that particular point. And that rate of change, as we're going to see, will change as we go along. As long as it's not if it was a linear function, rate of change is constant, right? Slope's always the same. But if we have a quadratic, rate of change is changing all the way along there. And we're going to actually, on Tuesday, we'll look up how to get that function of how things are changing. That's pretty good. How many of you know how to subtract 1? The technical side of just subtracting 1. Did you ever learn how to subtract 1? I hope so. Yeah, just minus 1, right? What's 4 minus 1? You're in good shape. Okay, that's all we, actually that's one of the, and how do you know how to multiply 4 times 5? That's how we take the derivative. So just to let you know, the arithmetic part is actually very simple. There will be a few things in the processing, but the Tuesday that's where we're going to start. Multiplying and subtracting by 1. That's all we got to do mathematically, okay? So, but it all comes from this. This is what we're working with. Now, what I want to do, we don't need all this verbiage and stuff because we're not going to go here like most calculus courses do. Hopefully this link is live. I'm not sure if it is or not. If not, I'll look it up again. But I think it should. That's not going to work. Let's see. I think if let's keep that. I think I might, well, let me copy it. I'll open it in a new window. Paste it. It's a GeoGebra outlet. And what it allows you to do is it gives you a function, and I didn't look at this a lot. Actually, you could put in any function you want here, but they've got a cubic, which is this thing, goes up, comes down. You see a maximum, a minimum. And then what you have is you have 2 lines. The green one is a secant line, right? The 2 points, A and A plus H. And the mauve color, purple, whatever that color is, that's going to be our tangent line. And the whole thing of this is we can actually graphically let H go to 0 by dragging it, and we see as the 2 points come together, the secant line becomes a tangent line. Okay. If we go too far, it becomes a secant line again. But you could come from either side, and you see that the limit, as we let H goes to 0, that secant line actually does become the tangent line. And so with that's the whole concept behind things. And if we accept that, because we saw it, right, this is the best kind of proof I like, because seeing is believing. I see I can come from the left or I come from the right, and yes, it becomes a tangent line. What that allows us to do now is just work with that tangent line. Okay. Not have to do any other mathematics with it. And the other nice thing about this is you can move the point A. So let me put H out here or something. So you could kind of see how it's different at different places. You know, like down here, I let the secant line come together. Oh, there's a decreasing slope, right? So the derivative at this point is negative. It's going down. If you come over here, the derivative is going to be positive. So we're going to see this connection between what we call the derivative, rate of change, slope of the tangent line. They're all the same thing. And that's the most important thing. Is that in math, oftentimes we use different words for the same thing because sometimes they, from one perspective, they're different. But in this case, all those things are the same. The rate of change, instantaneous rate of change, the slope of the tangent line, the derivative, they're all the same thing. Okay? And the derivative is what we do for half this class. The other half is antiderivative, which is just the derivative backwards. So as we get into our little shortcuts on Tuesday, learning those things, the second half of the class we'll learn those shortcuts backwards. Okay, we start with the derivative and we work back to what we started with, and that's calculus. So if I were to compare it to arithmetic, it's like you learn to multiply and then you learn to divide. In this class, we learn to take the derivative, which is the slope of the tangent line, and then we learn to take the antiderivative, which we're going to see is actually accumulation. So if we know the rate that something's been happening over time, we know how much we've accumulated, which is another very important part. But this is all we've got to do. So in your homework, which we're going to take a look at, we're kind of done, what we need to do is, how do I find the slope of this tangent line? What do I need to find the slope of the tangent line?
Can you use the other point, the -2 and then -1?
I need 2 points. I could use this one, because it looks like, but I'm not quite sure. But what I would do, and this, because in your homework, they'll give you a picture, they'll have something maybe just like this, and they'll ask you to find it. So what I would do is I choose convenient points. And convenient points are wherever it sort of crosses the crosshairs, like this one, 6, -1. That's I would say is pretty good. 2, 0 is a pretty good point. -2, 1 would be a good, I could use any of those to find the slope. And so, yes,
So is the point where the tangent line touches, is that just the like the limit of the secant line?
it is, in this case, it's a is equal to 1, so it's going to give us the derivative at the point x equals 1. Now notice it's got a y value, but it's going to be, I don't know, maybe 0.2 or so. I can't accurately get it, so I won't actually use it. But yes, what we're getting is the slope at that point. Because as I said, if I went over to 2, I can see that's going to have a different slope, right? So this gives us a specific slope at a particular value. And yes, it is the limit as a secant line, the second point, as that distance from the second point goes to 0. Or I just like to say, easy, as the 2 points become 1. Yes, that's exactly what it is. And as we move it, we do it. But in the homework, they're going to give you a shot like this and say, what's the derivative of the function at 1? Or what's the slope of that tangent line? Again, they may ask it in either way. The answer's the same. The derivative at 1 is the same thing as the slope of the tangent line that goes through 1. It's all the same. So what you're going to need to do is just choose 2 points. And let's see, I don't know. I'll take that one, and why not this one? So that's -2, 1 is a point, and then it looks like 6, -1. And remember, all we're doing is taking those 2 points, getting the slope of those, using those 2 to get the slope, and that's going to give us the derivative. So again, I just like to line it up this way. I subtract -2 minus 6 is going to give us a -8. 1 minus -1, that becomes a +1. So 1 plus 1 is 2. Take the x value, the change in x, move it down here. So you get 2 over -8, so a slope of -1/4. And it kind of makes sense if I, -1/4 means if I drop 1, I need to run 4. 1, 2, 3, 4. And it sort of works out. Drop of 1, run 4. Right? That's what slope means. Rise over run. So what we just found out is that the derivative of this function at 1 equals -1/4. Okay. There's like 3 or 4 questions at the beginning of your homework that's exactly what you're doing. But I remember I get students that laugh, how do I get the slope? They don't give me the function. They don't give me points. You got to pull them off. The other thing that happens, in fact, let me go ahead and pull those up just to show you. And from what we just did, that's you'll be fine on the homework. That's everything that the. So let's take a look, and then I've got a little bit more that I, kind of flesh things out a bit, but. Let's see. Come on. Oops, that's not the. I want this one. And incidentally, it might, I don't know, I never did it, but it might be helpful sometimes to look at the homework before you come, just to kind of see what we're doing. But you never know, sometimes kind of scares you a bit. So actually, it looked like, I think it was a different one at first, but what they do is they give you the point, here's our slope, here's our tangent line, and they estimate the derivative of it at the corresponding x value. So again, it's just find some values, and I think this one looks good. It looks like 3, 9, and it looks like it's going through 0, 0, so I would use those 2 points. Use whichever ones that are good. Just realize that occasionally you'll get points that look like they're going like 2, 6, that looks like it works. But since they don't give us the function itself, there's no mathematical way to do it. We just have to kind of look and estimate off of there. If it marks it wrong, check your work. If your work's right, sometimes we have this problem because I've looked at the software and I've looked at what they've done is they've got like 0.05 or something. What they did is they knew what the function was, so they actually figured that out analytically, and there's no way we can do that. All we can do is get as close as we can get with those points. Okay, so there's that one. There's this one. This one's probably the easiest one, right? Do you even have to do the calculation? It certainly looks like it's horizontal, right? But if you did the math, right, no vertical change, so there's a 0 on top, 0 over something, it's got a slope of 0. Okay, so that's kind of what we're getting at. This will have another slope. Again, just find the 2 points, find its slope. That's all it's really wanting. And notice it, find the slope of the tangent line, estimate the derivative. Those are going to be the same thing. But you look, well, I just gave it to them. What are they must be wanting something different, right? No. They want you to know that those are the same thing. Okay. And this one, they want you to compare which one's the greatest. Now, what I want to say is what's the slope of p going to be? What's the sign of the slope of p?
Negative.
It's going to be negative. A negative is smaller than a positive number. A negative is smaller than 0. So when we put it in order, the number might be bigger, so it might be a steeper change, but if it's negative, a negative number is smaller than a positive number. So we already know that looks like it might be 0, that's going to be positive. This has to be the smallest. Okay, so when they're asking you to put them in order, because I tend to think of a negative, if you just look at the magnitude, the size of the number, I would say -7 in a sense is greater change than +1. That's true, but it's going down negatively. So in their verbiage, positives are greater than negatives. Yes, sir.
So like, but like for Q, like since it would be like almost like no change compared to the other two, wouldn't that technically mean it's the least change?
No, because a negative number. Well, it's the least change, but that's the problem. They're just asking, and they say it here, the slope of the tangent is greatest or least. So the value is a negative number its value is actually below 0. So where it's thinking of a horizontal number line, 0's here, a negative number's to the left of it, so it's actually smaller. And actually, since it's a negative change, it's going down as well. So that's kind of, I know exactly what you're saying, because it's kind of like, well, 0 seems like a small number, and this has actually more change going on, because 0 is really no change. But when they're just talking the value of the slope. So it's kind of, later on we do talk about that, and we would talk about if it's got negative slope, it's got change, whereas 0 slope has no change. So some of this is learning how they're wording things. Okay, but this one works like that. Oops. And again, you get several of these looking for the greatest slope, the least slope. So I just want you to know that, because since there's only 2 choices here, I think your number of chances of getting it are probably limited, because that's how they, since it's multiple choice. So just, I wanted you to come into this. A negative slope is least in comparison to a 0 slope or a positive slope. So that's what you're kind of looking here. I say, okay, P is going to be a 0 slope, Q is a negative slope, R looks like a negative slope, and so, you might take either like the edge of a piece of paper. I have something. Anyway, you might want kind of put a straight edge against that to kind of see which one's going to be going which way. And in that way, if they're both negative, I would say 0 is actually the greatest. 0 is bigger than negative, so greatest ones, probably going to be P, Q, and R are going to battle it out for the least, whichever one's more negative. Okay, so that's that. I just want you thinking through those points, and that's what we're trying to get you to do, is graphically see that the tangent line, the line that goes through the graph at a single point, that is the derivative. And this whole lesson today is just about the graphical view of that derivative. Tuesday, we're going to get into the shortcuts to get the actual function, which is going to be kind of cool. But we're going to come and understand that that's what it is. And as we go along each of those points, right, that same function has different derivatives along that way. So the derivative itself we'll see is actually a function. Again, points and which one's greatest, least, which one's, actually this one they tell you this, there's one that's 0, has a slope of 4, has a slope of -1, and you just have to pick which one is which. So you don't actually have to calculate, but obviously the one that's 4 has got to be increasing, the one, so several of these type of things. They have ones with questions, which one is greater, so then looking at different points and their derivatives, and see what's happening over an interval. So from 8 to 16, what's happening here? So what would you say is happening to the slope of the tangent line along here? Is it getting bigger, or is it getting smaller? And again, the way I would do it, just maybe on your screen, have a straight edge of a piece of paper and sort of follow it along, have that tangent, and it'll show, oh, the paper's going up. Slope is increasing, the derivative is increasing, or no, it's going down, derivative is decreasing. Okay, but that's what we're looking at. Is we're looking at every single little point along there will have a tangent line attached to it, and what does that tangent line look like? This will get you thinking about the derivative in a visual sense that I think will help a lot more than when we went through and had you do a bunch of problems with that difference quotient, plugging it in and trying to get the derivative that way. In fact, that was the reason why I took calculus 2 times, because I didn't pass it the first time. Now you're scared, right? My calculus teacher didn't pass it the first time. No, I didn't. I'm not a math teacher because I'm smart. I'm a math teacher because I struggled. And I found my way through because I had a dyslexic professor who was able to help me get through those things. So, I don't love math. I don't hate it either, but actually I'd rather be teaching history. But I teach math because I can help people who struggle. And I don't harm anyone who doesn't struggle. So, whichever way you are, I won't hurt you, but I might help you. Okay, so again, in the homework, there's some questions, kind of go through these. And just remember, when it is multiple choice, I think, I can't remember, I think it's 4 or 5, you get maybe 2 choices at these. So try to read them carefully. I have problems with these because as I read things, my dyslexia is actually more on language, and so I twist language around, and sometimes I know the right answer, but I'll pick the wrong one because I read it wrong. But again, we'll get you through. We're looking for, what did I say constitutes 100% on the homework? Does anyone remember, or did I ever say it here for this class?
You said you'd round up.
I'd round up from, what did you need to get though?
I don't think you said.
I never said? I think I said 90. Did I say 50?
I don't know.
I know sometimes I say 70, sometimes I just can't remember. But I'll bet you, we'll set it at 80 because you'll get at least 80, So go through, but there's going to be some times, I just know with the system, where you actually have a right answer and it will mark it wrong, or it won't, because of some of the difficulties. So we won't worry too much about that as long as you're understanding. As long as you're getting an 80%, that's going to transfer over as all of the homework. Okay. But again, you could also, and the reason I could do that because the system won't give you the 5% extra credit unless you finish it all. So you could stop at 80 and I'll give you the 100%. So I guess that's like an extra 20%. But if you go to the 100%, the system will give you an extra 5% as long as you get done 24 hours before the due date. And I think that's the other benefit. I'll move all the due dates to Tuesday night's class. actually midnight at Tuesday. So as long as you get it done by midnight Monday, you'll get a 5% bonus if you get it all done. I don't think you have to get 100, but as long as you finish it all. Okay, so again, and this one, this is the graph of f, and then they want you to see what would the graph of its derivative look like. And so if we've got a straight line, what's going to be the slope of the tangent line along a straight line? Will it change? No, because when I first pulled this up, there's one with a curve, and yes, the slope will change everywhere. The slope is the same on every one of these points, so it's a constant rate of change. If you graph a function that's a constant, what does it look? What does the graph of a constant look like?
It's a straight line.
Straight line, which way?
Positive.
Horizontal. Y equals 3, say. So this is going to have a negative slope. I can see it looks like a slope of -1. So the graph of that function should be y equals -1. So that just to let you know that a straight line is going to have a. So kind of think through it though. You'll get through all of that stuff. And here's one with a curve. And again, that's the function. What would its derivative look like if I were to plot all the slopes? And you can kind of see, well, it's going to decrease. So the slope is going to be negative on this side and positive on that side. So kind of lead you through. There's a couple of those to do, get you to think about it. But notice it's all graphical. It's all graphical. Where is it increasing? Where is it decreasing? Because this is what we use the derivative for. It's rate of change. Where does it increase? Where does it decrease? So starting to look at graphs in terms of how they're changing rather than what values there are. Okay, and that's one of the hardest part of the calculus, is that there's two things going on. There's a function that gives us an x and y value. There's the derivative and what does the derivative give us? I forgot. Can anyone help me? Slope of the tangent line. What's the third word I could use for that? Rate of change. Instantaneous rate of change. Slope of the tangent line, instantaneous rate of change. What did you say?
Slope of the tangent line.
Slope of the tangent line. I thought there was a third thing. Was that? Rate of change. Anyway, it's all the same thing. Okay. So, but we have an x value associated with the rate of change. That's what the derivative function gives us. And some questions are asking about how much profit did we make? That comes from the function, the x value. At this time we made this much profit. That's the y value. Other questions will ask, how was the profit changing? That's when we use the derivative. So that's the other thing, is just kind of preparing you as we get deeper into the class and we're doing word problems. Those are two different types of questions. We want to know how much profit, that's the original function. We want to know how is the profit changing, that's the derivative function. And we're going to, we bring in there's some formulas and stuff that we use the derivative for specifically for business that involves, what, how many of you are in supply chain? One. Business management? Not decided yet? I'm still trying to decide what I want to be when I grow up. So, but yeah, so if there's some things we're going to do, supply and demand, and there's some really cool stuff that you're going to be able to do with that derivative, with that rate of change. Okay, but it's all graphical today. I was going, man, where's the plug-in? Where's all the algebra questions that we used to have? Oh, cool, they're all gone. So this is making. Not only do I think it'll make this process easier, but I think it's actually going to make it deeper, because you're going to now get a visual picture of what the derivative is. When we get you to the shortcuts, you'll be able to calculate the function fairly good, and then you'll be able to graph the function and its derivative side by side. And you kind of start working very early within we're in the third week, and usually we wouldn't get there till the fourth or fifth week. So we're getting there pretty quick into actual usable calculus. And we're done. Submit. Done. Okay? Any questions? Oh, maybe we should. I guess since I got the rest of this, why don't we go ahead and finish it? We'll click through, see if there's anything important. So this is a static picture. Again, what I want you to do is pull up that little thing, play with it, move it a little bit. It was kind of fun. Gives you the power. But this is a static picture. Yes, we start with a secant line. We let h go to 0, which means that we bring the 2 points closer together. When they touch, that gives us the tangent line. And that tangent line, again, it's defined geometrically as just the line that goes through the function at a single point. But it's also the rate of change at that point. Think about it, if this was a car and you were going around a curve and you hit black ice, what happens to you? When you lose your friction, you follow your trajectory. That's what this is doing. I did that once. Fortunately, I was going straight when it happened, but I was on the freeway from Portland to Seattle, and I did. But that way, so scary. I closed my eyes because I thought it was the end. Nothing happened. Because there was no other cars there too. So my sister and I always talk about that day. Go, we're still alive. We thought we both were going to die. Okay. So then, what is a tangent line? Well, the tangent. This could be a tangent line. So typically, we will say it only touches in one place, but sometimes because of the history, it's got to go back through here. So it looks like a secant line, but at this point, that's what the tangent line would look like. Okay, so we say it's only going through but it's sort of locally going through one point. But like in this case, there's no way to draw this tangent line without going through this, unless we stop it somehow. Sometimes, and sometimes it actually can go through. We're going to see that this is a very special point. It's called a inflection point, where the tangent line actually crosses over it. That's only does it at one point. Everything else it kind of just goes through one. But those can happen. But what the thing is that's happening, the reason we can use this to look at rate of change is on any given curve, as we zoom in, the difference between the curve and the tangent line, the closer we get in, is less and less. This is what we call local linearity. If you get close enough, everything looks like a straight line. And that's why we spend in mathematics so much time with linear equations. Because if we get close enough, everything is linear, right? And we use it for an analysis. And for some things we can zoom out and it is linear, but getting in close enough, that's what we get. And that's what the instantaneous rate of change is. The thing is we don't want to stick with the linear approximation for too long. We're going to see that because over time the function actually does change, and so we get, but for short periods of time, that derivative is very, very valuable for us. Okay. Oh, now we're done. So I told you there wasn't much else. It's just a graphical look. So no algebra to do. Arithmetic, right? We've got to find the x and y coordinates of 2 points. We do the slope formula. That will give us our derivative. That's what we're doing today. Tuesday, we're going to come back and we're going to actually look at the algebraic functions themselves, and we're going to find the rule, which involves multiplication and what else? Subtraction of 1. Not subtraction of anything else except 1. Just as long as you can subtract 1. If you have problems subtracting 2, you're still going to be fine. So as long as you can just subtract 1, we're going to be loving it. And then we'll actually get the function for the derivative, and then boom, we're right into deep calculus without too much algebra in our pathway. Wow, that was quick. Any questions? Forgot to ask if there were questions about the other homework or anything. We're all good? Okay. I'm still here. You got half hour if you want. You can hang out. If you got questions, we can work on them. Otherwise, have a wonderful weekend. When's the Super Bowl? That's 2, 3?
The 12th.
12th, okay. I was driving by there yesterday and I go, oh yeah, that's right, we got the Super Bowl here.